Let's move on to some practice. Construct truth tables for statement forms. This is not P or Q, then not Q. So remember what we did so far. I always encourage students to write down the truth tables. For example, P, Q, P and Q. Here you have true, true, false, false, true, false, true, false. True and true is true, true and false is false, false and true is false, false and false is false. PQ, P or Q, true, true, false, false, true, false, true, false. So you get a true, and a false. P and Q, P then Q. You have true, true, false, false, true, false, true, false. So true, then true is true, true, then false is false, false, then true is true, false, then false is true. So these are the important ones that you need to know. You can write down the biconditional as well. True if and only if true is always true. True if and only if false is false. False if and only if false is false. False if and only if false is true. So these are four basic operators and their truth tables. Let's take a look at the truth table for this one. Here you have two statements, 2 to power 2. You get four combinations, right? So let's write this down here. I'm getting P, Q. I have not P. I also have not P or Q. I have not Q, and then I have not P or Q, then not Q. So take a look at this. I have true, true, false, false, true, false, true, false. And then the negation of P, you end up with false, false, true, true. And let's combine these together. Not P or Q. I'm just combining these two now. So here you have true or false, which is true. False or false is false. True or true is true. True or false is true. Then let's erase this one. Then the negation of Q is going to be false, true, false, true. And finally, I'm just combining these two using implication, the order from left to right. So true then false is false. False then true is true. True then false is false again. And true then true is true. The next example is P and not Q, then R. Okay, so let me just erase these. And since now we have three statements, we're going to have 2 to the power 3 or 8 combinations. PQ, R, and then we have P and not Q, so we need not Q as well. We need P and not Q, then P and not Q, then R. Let us list these as usual. True, 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 and then false, 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 true, true, false, false, true, true, false, false. So again, this is not a unique way to list these. It just helps us to keep track of the combinations, all of the possible combinations, a little bit easier. Perfect. So let's take a look at not Q. You have false, false, true, true, false, false, true, true. Excellent. Now let's combine P and not Q. Here we go. So you have true and false, which is false, true and false, which is false, true and true, which is true, true and true, which is true, false and false, which is false, false and false, which is false, false and true, false, false and true, false. And then we're going to move P and not Q, then R. So the order is important. The hypothesis is P and not Q. The conclusion is R. So take a look. Here you have false, then true, which is true. False, then false, which is true. True, then true, which is true. True, then false. This is the only case that the implication is false. Then you have false, then true, which is true again. False, then false, which is true. False, then true, which is true. False, then false, which is true. Okay, let's take a look at another example here. We have P and not R if and only if Q or R. So let me erase these. Hope we got everything. And since we have 3 statements, we're going to end up with 8 combinations as before. Very well. So I need not R. Not R should be here. Let me use the same color. Then you have P and not R. Then you have Q or R. And finally, P and not R, if and only if Q or R. So for R, the negation is going to be false, 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 false. Then you have true, 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 and then P and not R. P and not R. These two, we are combining these two using and. True and false is false. True and true is true. True and false is false again. We have true and true, which is true. Then false and false, which is false. False and true, which is false. False and false is false. False and true is false. Then you're going to combine Q or R. So now we're looking at these two columns, Q or R. True or true is true. True or false is true. False or true is true. False or false is false. True or true is true. True or false is true. False or true is true. False or false is false. And finally, on our last step, we're going to combine these two using if and only if. Again, remember the behavior of if and only if connector. It's going to be true as long as both those statements have the exact same value. True, true is true. False, false, true. And in other cases, you get false. So take a look. You have false, true, false. True, true, true. False, true, false. True, false, false. False, true, false. False, true, false. False, true, false. And finally, false, false, true. So this is what we have for these compound statements, and these are the true values for these statements. In the next example, we're going to use the logical equivalence to rewrite the following statement. So the statement says, if x is more than 2 or x is less than -2, then x squared is more than 4. So what are we going to do? We're going to use the logical statement. Here you have P or Q, then R, which can be written as P then R and Q then R. So let us identify P, Q, and then continue. This is my P, this is my Q, then R. Now just write it as P, then R, and Q, then R. So P says if x is more than 2, then x squared is more than 4. Let's close up the parenthesis, and Q says if x is less than negative 2, then x squared is more than 4. So we rewrote the statement using another version of the compound statement. On the left-hand side, you have P or Q, then R. On the right-hand side, you're connecting the implication using AND.